Namaste, welcome back to the Pragna channel. You are watching AWS Cloud projects for beginner to expert levels, and we so far finished 87 projects, and today we are going to do 88th project as a machine learning engineer. So far, we did how many? Almost mm, nine. Nine projects as machine learning engineer. We have six more to go, including today's one. So let's go ahead and finish our 88th project, which is get home safe. So let's go ahead and learn about what this project is all about. And let's see what new things we are going to learn as part of this project. Hello there. Thanks for answering our call for help. We have a unique problem. Sure. Can you tell me more about your problem? We have built an autonomous car which is meant to make deliveries to hard to reach communities, including those in mountain regions. These cars currently run on monorails. However, during our testing, we noticed the drive motors are underpowered. During one particular hill test, the car got stuck at the bottom of a valley. Its motor was not powerful enough to return or climb the hill in front of it. The cost of purchasing extremely powerful motors is not feasible for us. Is there a way to use a machine learning model to overcome this issue? This is really an interesting problem. Do you have any concerns if my proposed solution causes the car to go back and forth? I don't see any reason for concern. The car is carrying non-flammable materials. Awesome. In that case, you can use an OpenAI gym mountain car environment with the Amazon SageMaker reinforcement learning framework to test the concept. Is this something you are willing to try out? Hmm. In our previous project, we have used gym, but what is mountain car environment? That I'm not sure. Let's learn. OpenAM Gym mountain car environment. I'm not familiar with the technology. I do know Amazon SageMaker though. OpenAI Gym is a toolkit for developing and comparing reinforcement learning algorithms. The mountain car environment provides a similar simulation of your problem. Wow, what a coincidence. Can you tell me more on how we can test this simulation using SageMaker? First, we need a wrapper code to import the OpenAI Gym environment to the SageMaker environment. We have done it in the previous project. Tic-tac-toe. We will train the model using SageMaker RL framework, similar to tic-tac-toe. The training job will interact with the mountain car game environment to find the optimum model. Looks like instead of tic-tac-toe, we are going to interact with another game, which is called mountain car game. Afterward, you can deploy the trained model as a real-time inference endpoint in SageMaker. You can also choose the endpoint type based on your requirement. Fantastic. We have a time crunch and I do not have much experience with SageMaker reinforcement learning framework. Can you create a short demo for us? Of course, I would love to. Thank you. I can't wait to see the demo. Similar to the previous project, it is going to be this almost same, except the algorithm that we are going to use is different. Previously, we used tic-tac-toe. Here we are going to use mountain car. Let's look at the video concepts, and these video concepts we have already watched, but if you would like to watch again, if this is your first video, then I would definitely recommend you to watch it. You can watch it in the playlist that will pop up here. Click on it, go search with the video title, watch them, and then come back. Let's look at our diagram steps, and this solution uses SageMaker Studio to solve the mountain car problem using a reinforcement learning approach. Reinforcement learning deals with interactive problems that make it infeasible to gather all possible examples of situations with correct labels that an agent might encounter. This type of learning is most promising when an agent is able to accurately learn from its own experience and adjust accordingly. The mountain car problem deals with a car at the bottom of a valley. The possible action is the acceleration that can be applied to the car in either direction. The goal is to reach the top of the right hill, which is this one. Amazon SageMaker RL uses environments to mimic real-world scenarios. Given the current state of an environment and an action taken by the agent or agents, the simulator processes the impact of the action, returning the next state and a reward. Presets configure the RL training jobs and define the hyperparameters for the RL algorithms. The training code imports the environment files and the preset files, and then it defines the main function. Use the SageMaker RL estimator to start an RL training job. The output from the training job is stored in S3 and the training model details are stored in SageMaker model. You can plot the metrics in a notebook by using Amazon SageMaker Python SDK analytics library. Real-time inference is ideal for inference workloads where you have real-time interactive, low latency requirements. A model can be deployed in SageMaker containers and in an endpoint that can be used for inference. Hyperparameters are a set of input features. Hyperparameter tuning optimizes a model for the metric that you choose. After changing hyperparameters, retraining of the model is required. This is an iterative process. This is something, remember in the previous project where we played tic-tac-toe, the initial hyperparameters that were provided were equal to the game being easy mode. So it was never able to beat me, right? I always won. It had no clue. But the second time we modified the hyperparameters, after that the tic-tac-toe game became hard. So it was able to win against us once, and all the remaining times it was a draw. It never let us win. Okay, so obviously hyperparameter tuning optimizes a model. To get predictions from the new model, deploy the model in a new SageMaker endpoint. To test the endpoint, you can pass the position of the agent. So let's go ahead and see what we will get to learn here. Practice lab, which will be similar to what we were doing. SageMaker Studio to import the code base, review the preset parameters, and then define the training task. Use SageMaker RL framework to train the model to solve the mountain car problem. Deploy the trained model to a SageMaker endpoint, test it. DIY, same, here we are going to learn, change the hyperparameter settings. I think in the previous example we have the learning rate as 0.001. Rerun the training job, create a new inference, test the job, which are going to be similar. So let's start the lab immediately. Let's start the lab. There won't be any files. So let's click next. As usual, we'll go to S3, we'll copy the URI of the zip file, and then we'll go to SageMaker Studio if you want to read the concept. And then we'll open the Studio Classic, or you can call it as Jupyter Lab. That's what it is. And then new terminal, then let's copy the S3 file into this environment, then unzip it, which is what we are doing here. And yes, once you unzip it, you will have the Python notebook. And the Python notebook is actually going to explain us. Okay, before that they are explaining this. So let's read this, shall we? Mountain car. A car is on a one-dimensional track positioned between two mountains. One, two. The goal is to drive up the mountain on the right. However, the car's engine is not strong enough to scale the mountain in a single pass. Therefore, the only way to succeed is to drive back and forth to build up the momentum. Like for example, like it will go here. Obviously, it is going to push here. Go up, up, and like that. I think we can read more on this here on the OpenAI Gym blob. Okay, let's go ahead and open the Python notebook. T3 medium, I think everything's default. So once we are here, we can go through the notes that is provided there. So I can skip all this. Okay, they ran it, they trained the model, and then here they are just printing different stuff. They are plotting. I think where did they deploy it? Somewhere here, I guess. No, not here. Yeah, here they are deploying it. Right, deploy. And I think they're predicting it. That's it. There is no lambda and all are involved here, so we are good, I guess. We don't have to do that extra step. Okay, so the lab is still starting. So I will pause the video and I will come back when the lab is done so that we can go ahead and finish this off. All right, the lab is ready. Did you see that they gave 4 5 hours? I don't know. I mean, anyways, most of the stuff they anyways did it and provided it for us. So not sure why anybody would need that much time. Maybe they can sit there and practice and write their own code, I guess. Unlike me, well, my point is not to write any code right now. My concentration is just to find out all the topics, all the algorithms that I need to study. That is the takeaway for me from these videos. Okay, it is ready. So let's click on Studio, open Studio. I know the process. I mean, we already like what this is what 10th project. Yeah. If you ask me the process before 10 projects, I would say I have no clue. But now if somebody asks me, I know what exactly to say. If somebody asks me how do we use SageMaker, how do we deploy it, right? These days what is happening is the BI team is actually having a separate data science team and IT is going to remain the same. So I belong to IT team. Okay. So they will ask us to set up the environment. If there are any models, they would ask us to deploy them and help out the data scientists or any other people. So at least for that purpose, we have to know this as well, right? So that is my point, my whole uh, that is what I am looking for right now. Yes, I am also looking to learn about how to do machine learning, how to write these models and how to tune them, etc. But that comes later on because we need to learn the theoretical. So for that reason, when I'm going through this, I'm making notes of all the algorithms that we need to learn, all the you know big words, keywords that I'm hearing. I'm noting them down so that I can go back and learn them. Okay, so clearly they don't have unzip. So let's install it. Okay, that is done. Now let's copy the zip file from S3. Then unzip. Okay, that's unzipped and it will be placed here. You can see that. Okay, what is this? Okay, that is the successful policy. Okay, you. Okay, I think it will make it now. Okay, that's the GIF. And we have seen similar files in the previous example. I think let's go back. I think they will be in the source. In the remember in the they have two presets. This is where they enter the hyper parameters. Yeah, here see that training steps, etc. Heat up, evaluation periods, learning rate. I thought they mentioned the learning rate to be 0. Okay, maybe for the rerun or the DIY, maybe we'll do that. Okay, let's not waste any time. Let's go here. Let's open this. And I think that should be fine. So let's go through the notes. Your problem is to reach the top of the mountain where you reside. You just realize that your car is underpowered to climb. Luckily, there's another mountain on the opposite side which can be used to gain momentum and launch the car to the peak. You will use your machine learning approach to solve this problem. Mountain car is a classic control reinforcement learning problem that was first introduced by A. Moore in 1991. You will use AI Jim's mountain car continuous VO variant to validate your theory. State car's horizontal position and velocity can be negative. Magnitude of push. If negative, push to left. If positive, push to the right. If positive, push to the right. If negative, push to the left. Reward plus 100 for reaching top of the right hand side mountain minus the squared sum of actions from start to end. A more efficient memory based learning for robot control. Okay, this notebook is tested using medium notebook instance to keep things simple. The amount of time in each episode from default of steps is extended to that. The notebook is based on this simple notebook available in GitHub. almost all the notebooks so far we have seen are actually from this. Make a you can just go and visit it. Uh, Go to GitHub and search for Amazon SageMaker examples. To get started, import the Python libraries you need. Set up the environment with a few prerequisites for permissions and configurations. Okay, we are importing them, and we are importing everything that we need. Run it. Set up the linkage and authentication to S3 bucket that you want to use for checkpoint and metadata. Okay, so for item in get buckets, okay, we are just searching for our bucket and we are getting its name, and then we are setting the output path, and then we are printing the path. It will be our bucket slash output. I think that's what it should be. The bucket path. That's it. Where is the output folder name? Okay, that I'm not creating any. And this is the job name prefix, a variable they are setting. Get the IAM role using role equal to sagemaker.get execution role, which is what we are doing here. A source.patientenvs.python, which we have seen here, this one, is created for the modified environments. Since you are using OpenAI gym environment and wrappers, you need a function that takes the classic control environments, continuous mountain car env, and wraps it with a time limit that specifies the max episode steps. So let's click pigmentize, it will show the entire code. Okay, that's it. I think pretty much this is all it has, but it is importing that continuous mountain car env. The, the presets that configure the RL training jobs are defined in the preset mountain car continuous clipped PPO, which I opened file, which is also uploaded in the here. Also see the DQN Python for the discrete environment case. Using the preset file, you can define agent parameters to select the specific agent algorithm. You can also set the environment parameters, define the schedule and visualization parameters, and define the graph manager. There, these can be overridden at runtime by specifying the RL coach preset hyperparameter. All right, so let's see the continuously that clipped PPO Python file, which we have seen all the parameters. The training code is written in the file traincoach.py, which is uploaded here. We create a custom SageMaker coach preset launcher, which sets the default preset maps and ties hyperparameters. So this is the traincoach.py. This is a program. When using SageMaker for training, you can set a GPU or CPU instance. The RL estimator is used for training RL jobs. What is it used? RL estimator. We have normal estimator as well. That is for the other training jobs. In order to train other jobs, for RL, it is RL estimator. So what are we specifying? Specify the source directory where the environment presets and training code is, which is this. Specify the entry point. As you can see, entry point, when you run this, where should you enter? Obviously training coach. Source directory, we are telling this one, and dependencies, we are telling there is a common folder as well. Specify the choice of RL toolkit and framework. This automatically resolves the ECR path for the RL container. Then define the training parameters such as instance count, job name, S3, which are shown here, which are common to all the jobs, SageMaker jobs. Specify the hyperparameters for the RL agent algorithm. They already said you can use RL coach preset to provide them at runtime instead of the file. Define the metrics definitions that you are interested in capturing in your logs. You are using variant of proximal policy optimization called clipped PPO, which removes the need for complex scale divergence calculations. And I have a request for all of you. If you have, an easy way, like think of me as a dummy when it comes to machine learning concepts. So please point me in the comments if you know any source or a book or videos, doesn't matter what it is, that explains these concepts like it would explain to a school student, right? I want something like that because I have no clue of any of these concepts and I want to learn from basics. So if you know any such awesome source that you think will help me, do post it in the comments. The output from the training job above is stored in S3. The intermediate folder contains GIFs and metadata of the training. Okay. Estimator current job name, S3 URL. Okay, this is all configurations. Okay, what is it? Did I miss running something? Yeah, I didn't miss this one. Oh yeah, that's what I missed. Okay, the RL estimator, it takes some time. Usually takes around 6 minutes. Okay, let it run. In the meantime, let's explore this. Once it is run, we can run this one. And the visualization, we will be looking at the data. We can pull, sorry, we don't have a data, right? What are we visualizing here? We can pull the reward metric of the training and plot it to see the performance the model over time. Okay, so once that is done, we can visualize it, how it performed. Uh, we did something similar in the previous one as well, where we have watched the rewards. We plotted the rewards. So how are we plotting it? Using the plot from the matplotlib, and x-axis. Okay, this is normal stuff. Let it run. And once we do that, we will visualize the rendered GIFs. And how are they doing that? The latest GIF file found in the, I think the one we have seen displayed. You can replace the temp GIF file below to visualize other files generated. Okay, then we will deploy it. I think pretty much that's about it. So let me come back once this is done so that we can run. And I think we have to wait when we deploy as well. But yeah, let's wait 6 more minutes for this to be done. So you were wondering, like, I mean, even this looks similar to the previous one, but the point here is to understand these files, right? It is very important to understand how they wrote this code and etc. But again, when I don't know anything about it, what will I explain? Okay, so I will show you this. Maybe you guys can look at them and understand something. For me, I'm doing this again to know in and out of these things, not to learn the concepts, just to see what are all the things that are involved. Then I'm noting them, each one of them. Then I'll go back and I will read through them. I will learn one thing at a time. This is too much advanced for me. Anyways, I'm downloading most of these zips. Um, if you need any of that, ask me in the comments. I think even on my channel page, I provided my email. You can email me asking for this. I can send you those. Okay, let's see. Is it done? Not done? Okay, let me pause. Okay, this one took more time than I thought it would, but that's all right. Okay, as you can see, yeah, it took almost 15 minutes, close enough. Okay, let's go ahead and run this one. Okay, it's giving us the job name, S3 path, and the trained model. Now let's go ahead and plot the rewards. And not in here. Where is the plotting? Okay, here we go. Training reward. Okay, looks like the rewards are increased. Here it was not consistent and then it did. And then the latest GIF file found in GIF folder is displayed. Copied GIF files to temp there is temp here. I think maybe on S3. Yeah, on S3. Those are the three GIFs found. I think they will pull them here. We have already seen this one. Okay, I think that's about it. And then, okay, we need, oh, this is new. They are asking us to provide the instance name. Which one did they use? Okay, they want X file lots. Entry point deploy mxnet coach. Run it. This is again going to take 6-7 minutes. And then we will have the output predictor predict sample data. We are throwing some. I think we are giving it a coordinates of where it is. I think based on that it is going to. Let's see. You will see the policy decides to move the car to the left, negative value, and similarly in the other direction, positive value. All right. So let's be back. All right. So the inference endpoint is ready. All right. You can test the endpoint with two sample. Okay, let's test it with one sample observation. Starting with the car on the right side, but starting to fall back down the hill. Negative value you can see. And this is going to be negative, and I think it will fall down to the positive value right side. Okay. I think pretty much that's about this one. I know it's not much because we are not creating the model because that is not the point of this, right? Like the point of this is how to use different models that are out there. We don't have to reinvent the wheel. There are already so many examples that they pointed out that we can use, but I think the remaining ones like giving the hyperparameters, etc., I guess that's what this is all about. Change the hyperparameter settings to epochs 10 and learning rate 0.005. Rerun the training job. Yeah, I think we can do this. Okay, I don't think they have the parameters here. Yeah. Okay, let's open. I think it's here. And if we go to epochs, I think it's already 10. Where did we see the learning rate? Yeah, here. And what is the learning rate they want us to put? Epochs 10, learning rate 0.005. But is it the right file? Okay, epochs fine 0.005. Okay, we increase that by 5 times. Save it. What is this? Okay, we have here as well. So which one is what? Where should we modify it? Here or there? That's let's see what they are because in task 3 code cell 8 are they talking about modify it in this here? Oh, they're optimization epochs, learning rate this one, okay, which are nothing but I guess here. Yeah, so where are they getting these values from? Oh, here. I don't know either. Let's undo this. And I don't think I touched this one yet, so that's fine. So let's go and give it here. And that's, I guess, what else? I think pretty much that's it. And it's ML M5 large. They want to save some money on it, I guess. But anyways, this one is going to take some time again. So let me run that. And I will also come down here where you'll be deploying it. So I think somewhere here. Okay. So we train the job. Once we finish training, we look at the data. Oh, hold on. Let me again go back to where it was. Yeah, train the job, then we look at the data, then we deploy it, then we test it with more data. I think pretty much that's all we are following. Okay, it is done finally. So let's go and print the job name. I think we would need that. Inference endpoint name, okay, not the job name. I don't think it is printing the endpoint name. And let's plot it. It looks something similar to the previous one. And I think even the GIFs would look the same. I don't think there will be any difference. Okay, it is starting slow. I think the numbers we increased maybe because of that. Okay, and let's deploy this. And this shouldn't take that long because last time I don't think it took that long. I think they asked us to deploy this one, right? If I am not correct, because I don't want to deploy something else. Yeah. All right, let's give a couple of minutes. All right, it is done. I think I can get the endpoint name right from here. Let's copy that. Let's test our model and expected, but you see these are very small values than the last time. We've got last time 0.17, but right now you can see last time we got 0.15158. I think this will be much oh, this looks the same. Okay, not much difference. Okay, I guess. Okay, let's go back. Let's paste this, validate. So, all right, so I have one more algorithm to go through, I guess, after this project. I noted it down. I think, at least I think I will start learning maybe at least five algorithms, whatever they are showing here. I know there are many of those out there, but thank you for your help. We are able to implement a similar solution, and now the delivery is reaching its destination on time. Okay. So the algorithm name is what? Gym mountain car problem. Gym mountain car problem. All right. So let's go ahead and do our quiz, and let's see who is going to win. Obviously they are going to ask some questions about the algorithm, I'm assuming, because there is nothing new we learned. It's been repeating since last 8 or so projects, which is good. The more I keep doing this, I guess the more I will remember how it works, because I think I did it after the five first project. I don't think I grasped anything. I was grasping slowly, but I guess right now, if you ask me what are the steps, I guess I can tell you guys what are the steps. Solutions architect wants to detect drift on resources by using cloud formation. Which resources can detect a drift? This has nothing to do with this project. We did it a while ago. Which resources can detect drift? I think it is cloud formation, but which one? An individual resource within a stacked provision? A stack of resources? I think it's a stack of resources. I will go with that. Pause the video and answer yours. This is how it works. Then we'll check who is correct. I think at the end of 5 questions, we'll decide who won. And I got it incorrect, of course. Which sections are included in Amazon CloudWatch agent configuration JSON file? Oh, these questions are like we did them a while ago. Um, Agent file, it has select the three, huh? Events, logs, one of them. Agent? I don't think so. I will go with this. Let's see what is the answer. Agent metrics logs. Oh no. Oh no. No, 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 no. No events. All right. Two out of two wrong. All right. I think I never started a quiz this bad. Which service does CloudWatch use to send alarm notifications? At least I got one right. I think they are out of questions on SageMaker. That's why they are not asking any questions. But I'll still do this. Just five questions, two more questions. What are the types of secret values in secrets? Mm, I think it is string table, maybe string table, string or binary. Even this is wrong. Okay, today I think it's not my day. All right, I think that's about it. This one doesn't have any questions related. It's not asking any questions related to this particular project, so it doesn't make any sense for us to do any quiz. I hope you enjoyed this project. If you do, then go ahead and like, comment, subscribe, and become a member on this channel. Thank you very much for spending your time here. See you in the next video. Have a nice day. Peace out.